Today's class I am going to teach about how to write the Verilog HDL code for implementation of NAND gate using 2:1 mux. So previous video we discussed how to implement the NAND gate using 2:1 mux. If you need it, kindly refer the video. Now we move on the session. So first I draw the implementation diagram for NAND gate using 2:1 mux. So it's an implementation diagram. So it's a 2:1 mux. The inputs are I0 and I1 and A is the selection line. So this I0 is connected to VDD or logic 1. So I1 is connected to B bar, Y is the output. So it's a implementation diagram. I0 is connected to logic 1 or VDD, I1 is connected to B bar, A is considered as a selection line, Y is the output line. So now I am going to write the Verilog HDL program. As usual, you first write module, then module name. So module name is mux 221. So mux 221 is the module name. Then within a bracket, mention what are the variables used in the diagram. So in this variable, we can use 4 variable I0, I1, A, Y. So A represents selection line. So I0, I1, selection line, Y. So these are the variables used in the diagram. So among these 4 variable, these 3 variable considered as input, this Y is considered as output. So I0, I1 selection line considered as input, Y considered as a output. Now I declare the input variable and output variable. So input I0, I1, selection. So these 3 variable considered as input variable and output. So output stored in register. So output result. So rich Y. So far you write the module name and input variable, output variable, declaration of input variable and output variables. Then always at star. So the star represent changing the input variable. So which variable is change the output, that represent star. So in this diagram here A and B. So A and B is change the output values. So always at star. Initial, begin. So here using case statement. So case, selection. So based on the selection line, the input value is connected to output. First case, the selection line is 0. So 1 tick B 0. So now output Y equal to I0. So when selection line value equal to 0, A equal to 0, so I0 value is connected to output. So Y equal to I0. Then second case, 1 tick B 1. So now selection line value goes to 1. So in this case, I1 is connected to output. So Y equal to I1. Then default. So Y equal to I0. So default value Y equal to I0. Then end case. Here begin. So close the begin using the statement end. Then end module. So it's a simple Verilog HDL code for NAND gate using 2:1 mux. Now come to test bench Verilog HDL code. Test bench. So as usual write module and module name mux 221 TB. So it's a test bench module name. Then declaration of input variable and output variable in test bench Verilog HDL code. So input declare as register, output declare as wire. So input declare as register and output declare as wire. So rich I0, I1, selection. So these 3 variable used for input variable. Then wire Y. So then next one, the Verilog HDL code module name is mux 221. So mux 221. Then device under test, NAND gate. Then declaration of instantiations. So I naught. So I naught equal to 1. So 1 tick B1. Then come to I1. So I1 equal to B bar not of B. Then selection line dot selection line. So selection line equal to A. So A is the selection line. Then output. So Y. So Y equal to Y. So declaration of instantiation, I naught equal to 1 tick B1, I1 equal to not of B, selection line A and Y is Y. Then initial begin. So initially A value and B value, so both the values are 0. So it's a truth table A0 B0, then A1 B0, then 0 1, then 1 1. So these two variables making 4 combinations of input. So begin A equal to 0, B equal to 0. So after 25 nanosecond, so here A value goes to 1. So initially A value 0, B value 0, then A value goes to 1, B value maintained as it is. So after 25 nanosecond, A value goes to 0, B value goes to 1. So after 25 nanosecond, A value goes to 0, B value goes to 1. Then after 25 nanosecond, A value goes to 1. So now A value goes to 1, B value maintained as it is. Then after 25 nanosecond, A value goes to 0. Now A value 0, B value 1. Then end. So end. Then next end module. So end module. So this is the test-to-bench Verilog HDL code for NAND gate using 2:1 mux. So I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos. Thanks for watching my channel. Thank you.